Good day, AdMath teacher and students. Today we're going to be going through the topic of remainder theorem. So our objectives today is to identify parts of a division problem, divide polynomials using long division and synthetic division, state the remainder theorem, use the remainder theorem to solve problems. My intention is not to take you back to primary school. However, we learned some very good principles in grade 3 and 4. So, 47 divided by 3. 3 goes into 4 one time. 1 multiplied by 3 gives us 3. When we subtract 3 from 4, we get 1. Carry down the 7 to make 17. 3 goes into 17 5 times. 5 multiplied by 3 is 15. And 15 subtracted from 17 gives us 2. Our solution is 15 remainder 2. Why did I take you through this? Is it that I think you don't remember how to divide? No, but there are some things we need to remember. The number that is divided is called the dividend. The dividend is divided by the divisor. The result is the quotient, and the remainder is what is left over. Now, these are some very important terms for today's lesson because they're not only used in arithmetic division, but also in polynomial division. So, division of a polynomial by a linear expression is similar to arithmetic division. Now, divide x squared plus 5x plus 8 by x plus 3. Now, as you can see, they look very similar. But there are some key principles we have to make sure we take care of when dividing polynomials. First, divide the first term in the dividend by the first term in the divisor. In other words, x squared divided by x equals x. And notice where we place that x. Now we're going to multiply x times x plus 3, which gives us x squared plus 3x. Just like arithmetic division, we're going to subtract x squared plus 3x from x squared plus 5x. Now, be careful when you're doing this. I've outlaid the notes here just for those who don't remember. So we're subtracting the expression x squared plus 3x from x squared plus 5x. So look to the right of the screen. Now, in front of the second expression, there's a subtraction sign. When we distribute the minus sign, that x squared positive becomes negative x squared, and that positive 3x becomes minus 3x. Then I grouped our like terms. So x squared minus x squared, that cancels, plus 5x minus 3x. The difference, 2x. Now we bring down the 8. So we have the expression 2x plus 8. So just like before, we divide the first term by the first term. So 2x divided by x gives us positive 2. Now we're going to multiply that positive 2 by the expression x plus 3, resulting in 2x plus 6. We're going to subtract the 2x plus 6 from 2x plus 8. Now again, I want you to be very careful when you're doing this because sometimes as students, we forget to distribute the minus sign. So again, when we distribute the minus sign, instead of having plus positive 2x plus 6, we actually have minus 2x minus 6. Then I go and I make sure I group my like terms. As you can see, So I have 2x minus 2x plus 8 minus 6. The 2x's cancel out, and we're left with 8 minus 6, which gives us 2. So our solution here is x plus 2, which is our quotient, remainder 2. All right, second example. Divide 4y to the third power plus 6y squared plus 14 by 2y plus 4. Now, before we go into the actual calculations, there's something I want to pull your attention to. Notice in the question, we have the y to the third power term, y squared term, but we don't have the y term. When I set up the problem for long division, I included 0y. This is very important because if you don't remember to include your 0y term either for polynomial long division or synthetic division, it will get your answer incorrect. All right, so let's do the calculations. 4y to the third power, first divided by 2y. What do we get when we do that? We get 2y squared. Now we're going to multiply that 2y squared by 2y plus 4. What does that give us? That gives us 4y to the third power plus 8y squared. We're going to subtract that from 4y to the third power plus 6y squared. And again, please remember to distribute your minus sign. So when we distribute the minus sign, look at our rough work corner, you'll see that 4y to the third power now becomes minus 4y to the third power, and the plus 8y squared becomes minus 8y squared. So when we do that subtraction, or when I group my like terms, we're going to get 4y to the third power minus 4y to the third power plus 6y squared minus 8y squared, which gives us a difference of minus 2y squared. Continuing, we bring the 0y down, and then we say 2y divided into minus 2y squared. That gives us negative y. We're then going to multiply that negative y by 2y plus 4. Now this gives us negative 2y squared minus 4y squared. And we're going to subtract that from negative 2y squared plus 0y. So when we distribute our minus sign, we realize that the minus 2y becomes plus 2y squared, and the minus 4y becomes plus 4y. We group our like terms. So negative 2y squared plus 2y squared cancels, and 0y plus 4y leaves us with 4y. We bring down our 14, and now we have 4y plus 14. We're going to divide 2y into 4y, and that gives us a positive 2. We're going to multiply that 2 by 2y plus 4. That's going to give us 4y plus 8. We're going to do the subtraction again. And again, look what happens when we distribute our minus sign. And after our subtraction, we're left with 6. The solution for this question now is 4y to the third power plus 6y squared plus 14 divided by 2y plus 4 equals 2y squared minus y plus 2 with remainder 6. Synthetic division. To divide a polynomial by a binomial of the type x minus a, we can use synthetic division. So the basic requirement to use synthetic division is that the divisor must be of the first power, which means that the x term or the variable should only be to the first power, and it should have a coefficient of 1. And it can be subtracted or added to any constant. So a is a constant, a real number. We're going to attempt to use synthetic division using a question we already know the answer for. Divide x squared plus 11x minus 19 by x plus 4. Solution is going to be x plus 7 with remainder negative 47. Let's see if it works out the same way as before. So first, we're going to start by writing negative 4. Where did we get this negative 4 from? So we're going to set our divisor equal to 0, and then we're going to solve for the variable. So x is equal to negative 4. So we write it up there all by itself. And then we're going to write the coefficients of the variables in decreasing order, which means that x squared is to the highest degree. So the coefficient of x squared comes first, then the coefficient of x, 11, and negative 19. Now, synthetic division is quite easy. You start by writing the x squared coefficient at the bottom. Bring down the first coefficient. Simple enough. And then we're going to multiply negative 4 times 1. And when we multiply that, we get negative 4. And then we add negative 4 and 11 to get 7. Let's go through that again in case you missed it. Negative 4 multiplied by 1 gives us negative 4. We add negative 4 and 11 to get 7. Then we multiply 7 times 4 and we get negative 28. I misspoke. We multiply negative 4 by 7 to get 28. We add negative 28 and 19, negative 19. And when we add negative 19 and negative 28, we get negative 47. Now, this is where students make their greatest error. The highest power in our dividend was x squared. However, the highest power in our divisor is x. So when we're writing our answers, we write it from x and a constant in this case. We always subtract 1 from the highest power. So if our highest power was x to the 4th, when we're writing our answer from synthetic division, it'd be x to the 3rd. So our answer, x to the first power plus 7, remainder negative 47. And remember, x to the first power is the same as x. Let's try another one. All right, let's do another example of synthetic division. So for this example, we have divide y to the 3rd subtracted by 3y plus 10 by y minus 2. As you can see, the divisor fits the structure of something that we can use for synthetic division, where the y is to the first power and its coefficient is 1. So as usual, we write that 2, but where did that 2 come from? We equate the divisor to 0 and we solve for y. So y minus 2 equals 0, therefore y equals 2. Place a 2 up top. Now there's something that you need to take note of before we write the coefficients to do our synthetic division. The highest degree here is 3 because we have y to the 3rd power. But as you can see, y to the 2nd power, or the term for y to the 2nd power, is not there. So when we're writing out the coefficients, y to the 3rd, we'll put the 1, where y squared coefficient would be, we're actually going to put 0. So as you can see, we have 1, 0, negative 3, and 10. So the first thing, we move the highest degree coefficient down. So we move the 1 down. And we say 2 multiplied by 1 equals 2. 2 plus 0, 2. Then it's 2 multiplied by 2, which is 4. 4 plus negative 3 is 1. 2 multiplied by 1 is 2. And 10 plus 2 is 12. So now we're going to write this out to see what our answer is. Now, because we're dividing by a y to the 1, our highest degree in our answer is going to be y squared. So this is going to be y squared plus 2y plus 1. Remember that last number in our synthetic division is always the remainder. So we have a remainder of 12. Now this is much easier in my mind than doing long division as long as you get the gist of it. But all you have to remember too is remember to multiply, then add, and just work. This is zigzag simplification. All right, so remainder theorem. Remainder theorem is the point of everything that we're really doing today. The lead up is just in case you can't remember the theorem and you get a question on your exam, you can go to either synthetic division or polynomial long division. However, if you remember the theorem, it makes your life much easier. So remainder theorem, what does it say? If f of x, a function, is any polynomial, and f of x is divided by ax plus b, then the remainder is f of minus b over a. Now, the first example we're going to do is just breaking this down to see what is this talking about. So, procedure. So we get a question, if f of x is divided by ax plus b, right? And you want to find the remainder. So then what do? Where do you get this crazy thing on the inside? Minus b over a. So we start off by saying, let ax plus b be equal to 0. And then we solve for x. Now what you realize that what happens when we solve for x, we get x equals to minus b over a. Now what this is telling us is that anytime we get a remainder theorem question or a division of polynomial questions where it's a linear expression being divided into a polynomial, we need to set the divisor equal to 0 and solve for the variable. This allows us to get the input of the function that will allow the output to be the remainder. So our last step then is then input x equals negative b over a into f of x to find the remainder. It's really as straightforward as that. Okay, we're going to jump into some examples and let's see if this works. Please remember, anytime you see these questions, equate the divisor to 0, solve for your variable, use your value and input it into your function, and your output should be the remainder. Example 2. Given that g of y equals y squared plus 11y minus 19, what is the remainder when gy is divided by y plus 4? So what do we do first? We set our divisor equal to 0. Y plus 4 equals 0, and we solve for y. Y equals negative 4. Now to get our remainder, this negative 4 will be the input to our g of y function. So input negative 4 into g of y, and we get negative 4 squared plus 11 multiplied by negative 4 minus 19. So when we expand our brackets, we get 16 plus negative 44 minus 19, which equals negative 47. So our remainder for this question is negative 47. If it looks familiar, we've done this question 2 times in this one session. I'm just showing you that there are 3 ways to do this one question. For me, I think remainder theorem is the simplest. You might prefer long division or synthetic division. Example 3. Now, I'm not going to solve example 3. I'm going to give you about 2 minutes to try it on your own, and then I'll just display the answer. Did you get 23 for your answer? If you did, good job. If not, that's okay. Just check your work over and see where you made your mistakes. Example 4. Now notice there's something different with example 4. The x coefficient is not 1, but we have another constant there. So, given that f of x equals 4x to the third plus 6x squared plus 14, what is the remainder when f of x is divided by 2x plus 4? Now, one good thing you notice about remainder theorem, you don't have to write in 0 for the x term. It's not necessary. So what do we do first? Just like before. We equate the divisor to 0. So we have 2x plus 4 equals 0. And then we solve for x. Now when solving for x, we get x equals to negative 4 over 2, which can be simplified to x equals negative 2. Then we take this value and we input it into the function. So input x equals negative 2 into f of x. F of negative 2 is equal to 4, negative 2 to the third power, plus 6, negative 2 squared plus 14. Now, simple arithmetic after that. Our remainder here is 6. Notice how much easier this is in compared to doing polynomial long division. So example 5. Given that g of y is equal to 10y to the third plus 6y squared minus 9y plus 10, what is the remainder when g of y is divided by 5y minus 2? Now, just like all the examples before, the first thing we did was set the divisor equal to 0. Solved for the variable. In this case, it's going to be equal to y equals to 2/5. Then, to solve for the remainder, we input 2/5 into g of y. Now, after this, we work what is in parentheses and we do the arithmetic. And we get equal to 0.64 plus 0.96 minus 3.6 plus 10. We get a remainder of 8. Applying remainder theorem. Find the value of r such that x to the fourth minus 7x plus 4r has a remainder of negative 2 when it is divided by x plus 3. Let's start by naming the polynomial. But what do we know? If when f of x is divided by x plus 3, it leaves a remainder of minus 2, that's enough information for us to start the basic work. What do we always start with? Let's setting our divisor to 0 and solving for x. If my input to the function is negative 3, based on a remainder theorem, I should get a negative 2. This gives me enough information to make an equation, as you see below. Negative 3 to the fourth power minus 7 multiplied by negative 3 plus 4r equals negative 2. So, using that equation, let's solve for r. Negative 3 to the fourth power is positive 81. Subtract 7 multiplied by negative 3 is negative 21, plus 4r equals negative 2. Now when we combine the like terms on the left side of our equation, we get 102 plus 4r equals negative 2. So we get 4r equals 2, negative 104. Therefore, r equals negative 26. Theorem. Let's see another one. Applying remainder theorem. Find the value of p such that f of x equals x to the third minus p squared x squared plus 2x minus p has a remainder negative 5 when it is divided by x plus 1. Now, just like before, we have a function and we have a divisor. So, what do we know? Based on remainder theorem, if f of x divided by x plus 1 equals negative 5, that means we start off by equating our divisor to 0 and solving for our variable. So x plus 1 equals 0, which gives us x minus 1. Now when we input x minus 1 of f of x, if remainder theorem holds true, we should get negative 5. That means we have enough information to create an equation. So when we input negative 1 into f of x, this is what we get. So solving for p. Using the equation, let's expand our brackets or distribute. Negative 1 to the third power is negative 1 squared times p squared. Negative 1 squared equals 1. Multiply that by p, we still have minus p squared. Positive 2 multiplied by negative 1 gives us negative 2. And negative p is unchanged, equal to negative 5. Which will give us p squared plus p minus 2 equals 0. Now at this point, we're going to have to factorize and solve. When we do that, p equals negative 2 and p equals 1. Thank you for working with me today. I hope this video helped in clarifying how to and what is remainder theorem.